Alright, so this is the last lesson for this unit, and we're going to be talking about relations and functions. We did something similar yesterday when we graphed relations and functions, but today I'm going to actually define the difference between the two. So a function is just a relation that has for every input exactly one output. So it's a relation where for every input there is exactly one output. Okay, so I want you guys to write down this definition because this is the kind of a formal definition, a mathematical definition of it. Now I'm going to go down here and say a relation is just a set of ordered pairs. So it doesn't have anything special necessarily about it. So any set of ordered pairs, so like 3, 6, 7, 8, 10, 2, doesn't really matter. If you were to draw this out, since you have x inputs and y outputs, this represents a relation. So a bunch of just points could represent a relation. Okay, so a function is a special type of relation where for every input there's exactly one output. So what I'm going to do is try to explain this in terms of a birthday. Okay, that's why I have this little, little birthday cake here, to try to make this a little bit more of a formal definition for you so that it makes more sense rather than just mathematical mumbo jumbo. Okay, so I just want to go over really quick and talk about the collection of input values. We are used to calling that the domain. So the domain is your input, the output are your y values, so the range. Okay, and we've used these terms before. And again, so a function just has for every input there's exactly one output, and two or more inputs can have the same, oops, that word's not showing, but can have the same output. Okay, so again, this is your technical, mathy definition. I'm going to try to break it down so that it makes a little bit more sense. Okay? Okay, alright, so I figured you guys should meet Tank and Walt since they are always making tons of noise in the background. So this is Tank and this is Walt. They're going to help us to explain the term of function in terms of the birthday function. Okay, so you're going to think of Tank and Walt as your inputs of a function. So that would be your domain, right? So Tank and Walt are two separate inputs. Now their outputs, in this case, since it's the birthday function, would be their actual birth date. Okay, so I don't know Tank's, or actually I know Tank's birthday because I got him when he was a puppy, but Walt, he's adopted, so he doesn't know that. Don't tell him. But I just made up his birthday. So Tank's birthday is on the 28th. Walt's birthday is on April 28th. Okay? And again, I made that up. This represents a function. Your input has exactly one output. So Tank has one output, and that's his birthday on the 28th. Walt has one output, and that's his birthday on April 28th. Now, that's not to say that there could be more than one person with the same birthday, right? Walt and Tank are not born on the same day, but other people can all be born on the same day. So for example, Lady Gaga, Vince Vaughn, and Tank all have the exact same birthday on March 28th. Okay? Now, this represents a function still because you have multiple inputs with the same output. That's okay, but Tank cannot have two birthdays. He cannot be born on two separate days, so your input cannot have two different outputs. This would not represent a function. So to, go back to this. Every input has to have exactly one output, okay? More than one input could share the same output, but one input cannot have multiple outputs, so this would be not okay. All right, so that's the idea of a function. So again, this is the more boring idea of it, but you're just finding for every input there's only one output, so each person can have only one birthday. Two or more inputs, though, can have the same output, so two or more people can share the same birthday. Okay? Alright, so what we're going to do is start graphing stuff, and we're going to decide whether it's a function or a relation. Alright, so let's talk about y squared equals x. So if I make my xy table, this is your input, this is your output. Let's say I plug in -2 for the input. Well, if I square something, will I ever get the number -2? Nope, that won't work. So I actually can't use -2 here. So I'm going to do this backwards again like we did yesterday. I'm going to start instead by picking y values and then figuring out what my x values are. So let's say I plug a y value in of -2. This time I get a +4, right? I get a +4 if I square -2. I get a +4 for the x value. If I plug in -1, I get a positive 1 for the x value. If I plug in 0 for the y, I get 0 for the x. If I plug in a positive 1 for the y, I get a positive 1 for the x. And if I plug in a positive 2 for the y, I get a positive 4. So think about this in terms of birthdays. This is like seeing tank twice, right? 4 and 4. This is tank, the same input, having two different birthdays, okay? Or think of this one as Walt. Walt has appearing twice here, and he now has two different birthdays. This is not a function. This would be a relation, because you're seeing multiple inputs, the same input with multiple outputs, right? 4 has an output of -2 and 2. That is not okay, all right? So this would not be a function. This would be considered just a relation. But we can still graph this. So when we graph it, we have 4, -2, and 4, +2. We also have 1, -1, and 1, 1, and then 0, 0. So we get a parabola, a sideways looking parabola. We still get a parabola here. So this is the graph of a relation. Now our domain, we can look at it based off of our picture, or we can look at our table too. Remember, we couldn't plug in any negative values here. So our domain here is going to be x is greater than or equal to 0. And again, you're starting at 0 here, and you're working your way all the way to positive infinity here. For the range, you do not have a low point and a high point, because this goes forever to positive and negative infinity. So this is going to be all reals. Okay, let's look at graph 2. So graph 2, when I create my xy table here, I again pick values for the y. So let's do -2 to +2. So if I plug that in, I get 2, 1, 0, 1, and 2. And again, I'm seeing, look at this, like as tank. Tank has two different birthdays. Walt has two different birthdays. That doesn't quite make sense for a function, so this is not a function. Right away you can tell this is a relation. If I plot these points, 2, -2, 2, +2, 1, 1, 1, -1, and 0, 0, I get an absolute value graph of V shape that has been shifted, okay? So the domain of this function, again, you can look at these x values here. You're noticing that they're all positive or greater than 0, and you can see this also repeated in your picture, because you have x values that are all greater than or equal to 0. And your range, I could plug in anything for this range, any number that I want, and I would still get an x value. So this goes to positive infinity, negative infinity. This is all reals. Okay, now a faster way to test whether or not something is a function or a relation is called the vertical line test. You might have heard this in Algebra 1, but it's a really simple test. So the vertical line test says that if I pass through a vertical line, so if I create a vertical line anywhere on a graph, if it passes through the function just once, then it's a function. Over here, though, if I create a vertical line, see how I have two of the same points that are intersecting this vertical line? This is like having the same x input, right? The x value here is the same. So that x value here is the same as that x value down here. The y coordinate, though, is a different number. These y coordinates here and here are different values. So this is like tank having two different birthdays, okay? So the vertical line test says that if you'll have a function if it only passes through that function once. It's not a function if it passes through more than once. So in this case here, this would be a relation, and this up here would be a function. And we can go back to our graphs over here. Neither of these, we decided both of those, right, were relations. Neither of them, if I just draw a vertical line through them, they don't pass the vertical line test, because there's 2 points of intersection, right? 2 points of intersection for each one of those. No matter where I draw that vertical line, I'll always get 2 points of intersection. Okay, so this is just some pretty easy examples of determining whether or not something is a function, and then stating domain and range. So our domain here are just the numbers 1, 2, 3, and 4. Our range would be, if we write from smallest to largest, -3, 0, 4, and then 6. You don't have to write it in smallest to largest, but I like to do it that way. Is this a function? All right, so you've got 4 different people, each with different outputs. So that's like having 4 different people with 4 different birthdays. Absolutely, this is a function, okay? This next example, the domain, you have -1, 3. -1 is repeated, and then a 7, okay? So I'm not rewriting -1 in there. For the range, I have 4, -2, 1, and 10. I didn't really write that in the right order, but that's all right. Now, when you're looking at this, you have again, this is like Tank having two separate birthdays. This is not a function. That's not okay. That's only a relation then. In this next picture, this is called a mapping, where you decide whether or not it's a function by looking at the inputs and comparing it to the outputs. So here you've got 0 going to just one output and 2 going to just one output of -7. This is like two people, right, having the same birthday. That is okay. You have another person and a different person having two separate birthdays, so this is a function. Now in the second example, you have the point -1 here. -1 is being mapped to -3 as well as 0. So this is like having two different birthdays for the same person. So this is not a function. This would be called a relation. Okay? The last two examples here are visual. Alright, let's state the domain and the range first and then decide if it's a function or not. So the domain of this function, we have a left, so you want to think of domain, right, as your walls. I know with my students I always talk about, think of the walls caving in. So this is no longer inside your domain, neither is this. So your domain is restricted to only these values here, between -4 and +7. So when you write that, you're going to put your smallest amount first, then x in the middle, and then 7. Notice I'm using less than or equal to symbols every time. So your symbol should always be facing that direction, like that. They're eating the next value. You can think of it as a fish eating the fish that comes after it. So make sure you have also the equal to sign, because this is a closed circle for both of those. Now for the range, this time you're shrinking the ceiling and the floor, right? So for the range, you're looking at the low point here and the high point. So you're ignoring all of this is not in the range. We're going from a low point here of -7 to a high point of 6. So -7 is less than or equal to y is less than or equal to 6 would be the range here. Alright, now, is this a function? Well, since this is just a picture of a graph, it's very easy to tell if it's a function or not. We don't have to check every single point. All we're going to do is pass the vertical line test here. So every time I create a line through, a vertical line through there, I only pass through the function one time. So this is a function, okay? You don't have to do multiple ones. You can just scan it and see, if I pass a vertical line anywhere on this point, or on this graph, would it intersect more than once? It doesn't, so that's why it's a function, okay? Alright, this next picture, the domain of this next picture, if we shrink our walls, on the left side, the wall comes all the way to -7, right? But this is showing it's continuing forever and forever, going into positive infinity. So that means I have a low end, like a left value for x, but when I move to the right, it doesn't ever end. So that means that x should be greater than or equal to -7. All values are going to get greater than or equal to -7. For the range of this function, I have a floor, right? The floor is at -4. None of this is in there, but there is no ceiling because this keeps going forever and forever. I know it doesn't look like it's going up, but eventually it'll keep increasing forever and forever in the positive y direction. So this has a low point at -4 and increases, so y is greater than or equal to -4. Now when you ask if this is a function, if this passes the vertical line test, then it's a function. But no matter where you draw your line, you're going to always intersect here twice, except for, I guess over here because this is stopping. But within here, this is not a function. Okay? So this is just a relation. Alright, this is the very last lesson for chapters 1 and 2. Woohoo! We're done.